Welcome back to Remote Sensing Applications using ArcGIS. Most of us started working with GIS features, in other words, points, lines, or polygons. And because we're more familiar with features, sometimes surprises pop up when working with remotely sensed raster or images. In this video session, you'll investigate some of those raster surprises that are unique to rasters, and they don't exist typically with points, lines, or polygons in GIS. So the first thing we're going to do is create a test raster. To create a test raster, use a text editor and enter the keywords number of rows, number of columns, cell size, the x-coordinate of the lower left-hand center pixel, and the y-coordinate of the lower left-hand center pixel. And then we'll fill in, we said we're going to have 5 rows, so we'll have 5 lines of data. And we said we're going to have 5 columns, so we'll have 5 columns of data. So make a little text file like this containing data ranging from 1 to 9. So basically each row sequentially is 1 greater. So 1, 2, 3, 4, 5 would be the first row. 5, 6, 7, 8, 9 will be the last row. So make that text file, and then we'll create a raster from that text file for our test objectives. Okay, so after you've made your test raster text file, I use Notepad to make mine. Save that to your text file, and then start ArcGIS. And then use the search window. We're going to search for a tool called Ascii to Raster. And that is a tool that allows you to convert text files that are in that special format where we have the keywords, number of rows, number of columns, cell size, X lower left-hand center pixel, and Y lower left-hand center pixel. So we'll find that tool, and then we'll run that tool to create a test raster. Okay, so I browsed to the folder that contained my text file, and then I'm going to name my output raster test raster 1. And then we have an option of creating floating point pixel values, which would be containing decimal points, or integer, which would be whole numbers. So we'll use floating point in this example. And then OK, and that will create our test raster 1 raster. Okay, so we have our test raster, and it's ranging in pixel values from a low of 1, which would be this pixel, to a high of a pixel value of 9 for this pixel. And the one thing that's strange is if you don't give an extension, by default, ArcGIS stores rasters as an old-fashioned format called an ArcInfo grid format. So if we look at the properties of this test raster, the format is a grid format. And I don't recommend that you store rasters in a grid format because it's a very awkward format that's very old-fashioned. So for example, if we look at where this is stored, it's in the test folder. And a grid is actually composed of 2 different folders for every raster. So the attribute information would be in this folder, and it's just in files that really have no meaningful names. You don't know what's inside arc000.nit, for example. And then some of the raster information is in another folder. And once again, if we look in that folder, it has a lot of things that we don't understand what's really in W00101ADF or W100.101x.ADF. So don't store rasters as grids. What you want to do is give your output an extension and store them as typically geotiffs if you're going to a folder, or store them in a geodatabase as a geodatabase raster. So what we'll do is we'll rerun our Ascii to Raster tool if we go to the Results tab, and then we'll rerun this tool, and this time we're going to output to the same folder, but we'll give it an extension test raster 2, and the extension will be .tif. And that way it'll be a GeoTIFF raster, which is a much better format compared to a grid raster. So now we have a GeoTIFF raster, and we could have named it any long, meaningful name we want. And basically, it's just this one raster. We could email somebody, and they could basically use this one raster in ArcGIS. It has some companion files. So, for example, an XML file that would have metadata, but that could always be generated from the original source raster. So we have this simple raster, test raster2.tif, and it's a much better format for rasters compared to this old-fashioned grid-based system. Okay, so if we're working with points, lines, and polygons, we have a point attribute table, a line attribute table, or a polygon attribute table. With rasters, one of the surprises is you may or may not have an attribute table. So for example, if we look at this TIFF raster, it has values going from 1 to 9. If we right mouse click on it, open attribute table is disabled. So there is no attribute table associated with this raster. And the reason is rasters that are floating point rasters, in other words, the pixel values contain decimal places, will not have an attribute table, because the assumption here is that the pixel values represent quantities, and each pixel is likely to have a unique value. So for example, one pixel might have a value 0.333, the next pixel might have a value 0.567. So we could have millions of different unique pixel values, so it wouldn't make sense to make a value attribute table for some floating point rasters. So basically you cannot make a attribute table for a floating point raster. If you have integer rasters, then you will have a raster attribute table associated with that integer raster. And the reason is, the assumption is those integers represent categories, and a lot of times you want to know, well, how many pixels are there in each category? So we'll make an integer raster. So if we go back to our results tab and rerun our tool, this time we'll just use the drop down and make an integer raster. Okay, and then we'll call this test raster3.tif. So with test raster3.tif, we have the same values, but now it color codes them because it basically says, oh, I see an integer raster. Those probably represent categories, and it just assigns whatever random colors there are for each category, and you could change those by just double-clicking on the symbology. So for example, let's say category 1 is water. You could say, well, let's give that some water color. And category 2 is sand. Let's give that some sand color. So we'll give it a sand color, and etc. And if we look at this raster under properties, it is an integer raster. So integer rasters will have raster attribute table. So then if we look at our raster attribute table, there's the raster attribute table for this integer raster. So basically, for each value, how many pixels are there for each value? So in this case, for the pixel value of 8, there's 2 pixels that have a value of 8. And for a pixel value of 9, there's 1 pixel that has a value of 9. If we right mouse click and sort descending, the most popular value is the value of 5, and there's 5 pixels that have that value.